Hi students, the topic for today's class is Functional Dependencies and Normalization. So in the previous class we have seen about different views, integrity constraints and assertion in SQL. So what is a view? View is nothing but it is a select statement where we select different attributes from different tables, we consolidate those details and we submit to the users. Views are of different types: simple view, complex view, inline view and materialized view. Then we have seen different integrity constraints like check, default, unique, not null, primary constraint and foreign key constraints. And finally we have seen about assertions. Assertion is also like a SQL statement where it will always check for a condition in a database. So these are all the concepts which we have seen in the previous class. Now coming to the topic, today's class we are going to see about functional dependency. So what is a functional dependency? Where it exists? A functional dependency is nothing but it is a relationship between two attributes of a relation. For example, take the student details table. We have four attributes: student name, subject, mark and department. So here one attribute is dependent on the other attribute. For example, so see here the department attribute, it is dependent on the student name. Now we have the department details. With department details alone we cannot analyze anything. So only if we have the student name, so we can tell that student A belong to this department, student B belong to this department, like that. Similarly, the mark detail, it is dependent on the subject attribute. So here we can say department, student name uniquely determines department and subject, it uniquely determines the mark. Now you may ask me a question: is functional dependency exist in all relationship between the attributes? The answer is no. A functional dependency exists if one attribute uniquely determines the other attribute. Now what is uniquely determined? You can see in the picture I have given different colored rectangle and oval shape. So in the first column you can see red color rectangle, green color rectangle, blue color rectangle and black color rectangle. Now let us take the red color rectangle. So the red rectangle, it determines a brown oval. Similarly in the second column you can see again the same red rectangle, it determines the brown oval. So what we can do? We can say that is your red color rectangle, similarly the blue color rectangle, they are determining the same color oval. So we can say the red and blue rectangle uniquely determine its oval shape. Whereas you take the green color rectangle and the black color rectangle. The green color rectangle in the first column, it determines a purple color oval. Whereas the same green color rectangle, it determines a brown color oval, which means all these can be taken as attributes. So in one case it determines one attribute, in the other case it determines another attribute, means we can say it is not uniquely determining. Okay, so the part is red color and blue color rectangle uniquely determines their ovals, whereas the green color and black color rectangles does not uniquely determine their oval. Let us understand this concept with an example. So take the student table. You have three attributes: student ID, student name and phone number. Now let us take the first two columns, student ID and student name. Now in student ID each entry is unique, whereas in student name you can have repetition of data, like see in first record Meera, the second one is John, again it is repeated, the fourth one is Peter and fifth one is Meera. So you can see there are repetitions of data in the student name. Now if suppose I have the student ID, means I can uniquely take the value of student name. So I can say student ID, it uniquely determines the student name. But with student name and phone number, if only I am having the phone number but I am not having the student ID, I am having only the student name, means I will having some confusion with the phone number, because there are two phone numbers which are matching with each other, like 1 2 3 4 5 6 7, again 1 2 3 4 5 6 7. So the student name corresponding to this phone number is Meera, but you can see in the second and third values, that is 2 3 4 5 6 7 8, this also belong to the name called John, and 3 4 5 6 7 8, this also belongs to the name called John. So I don't know which John has which phone number. So this is what I mean, that student name does not uniquely determine the phone number, but with the same case, if I relate the phone number with the student ID, I can easily retrieve the phone number of the respective person. So student ID uniquely determines student name, but student name does not uniquely determine the phone number. In the second case, there is a table called student project. So the student ID, project code and project name is given. Here the student ID is also one primary key and project code is also another primary key. So a combination of student ID and project code, we can easily determine the project name. Now coming to functional dependency. Now there is a relation called X and another relation called Y. Now I am just implying X equal to Y, where X is a determinant and Y is a dependent. So this kind of relation we can say Y is functionally dependent on X. That is, Y is meaningful only with the presence of X. If X is not there, then we cannot retrieve or do any operation with the relation Y. Types of functional dependency. So functional dependency are of trivial and non-trivial, multi-valued functional dependency, transitive functional dependency, full functional dependency and partial functional dependency. Trivial and non-trivial functional dependency. So here you can see the relation. Trivial means if X tends to Y is trivial, if Y is a subset of X. That is, if there is a relation between two attributes, X tends to Y means your second attribute should be a subset of the first attribute. Example, here you can see student ID comma name tends to name, where student ID comma name, it is of one relation X, whereas name in the right hand side it is Y. Similarly, student ID comma name, it tends to student ID, then student ID tends to student's ID. So this is what trivial functional dependency. In non-trivial functional dependency, X tends to Y is non-trivial if Y is not a subset of X. See, you can see the example, student ID comma name are the two attributes that uniquely determine the phone number. Multi-valued functional dependency. So let us consider the table student activity. Now I have name, course and sports. Three attributes are there. My name uniquely identify the course detail as well as my name uniquely determine the sports detail also. So here the course and the sports are independent attributes, but they depend on the name attribute. Then transitive functional dependency. Transitive functional dependency means if suppose there is a relationship between two attributes, say X tends to Y and Y tends to Z, means I can take the form X tends to Z, that is Y is uniquely determined by X and Z is uniquely determined by Y, means I can uniquely determine Z with the help of X. Say student ID tends to name and name tends to phone number, means I can uniquely determine phone number with the help of student's ID. Then full functional dependency. Now if there is a relation like AB tends to C, where A, B, C all are attributes and A, B are candidate keys, that is both are considered to be a primary key. Now if this is the case, then the relation A tends to C or B tends to C, it should not hold. That is, if I remove any one attribute from the candidate key and still a dependency exists, means then dependency it should not exist, means then such dependency is called full functional dependency. That is, both the attributes should be there in order to determine another attribute. The absence of even one attribute should not exist. So then such kind of dependency is called full functional dependency. So example here, employee ID, department ID, it tends to employee name. So employee ID and department ID both are said to be primary key. Together we call it as candidate key. Now if I am removing the employee ID from the candidate key, then my relation is department ID tends to employee name. It should not hold. So this is a full functional dependency. Partial functional dependency means the removal of any one attribute from the candidate key and still the dependency exists, means then that case is called partial functional dependency. Example is employee ID, employee name, department ID, department name. So here employee ID, department ID both are primary keys. I am removing the department ID here and still my relation employee ID tends to employee name exists. So this is what a partial functional dependency. So these are all the types of functional dependencies. Now let us see some of the Armstrong's inference rules. Okay, so these are all the rules which are pertaining to the functional dependencies. So the primary rule is rule number 1. It is called reflexive. Now an attribute y, if it is a subset of x, then we can say x uniquely determines y. Example, that is the first name and last name attributes, they are the subset of last name, means then I can say my first name last name uniquely determine the last name. The second rule is augmentation. That is, if there is a relation like x tends to y, then I am adding a attribute to each attributes. XZ tends to YZ. Okay. So example is register number tends to first name last name. Now I am including address to the left hand side. So that left hand side relation is also replicated in the right hand side, which means address is appended to both left and right attributes. So register number address tends to first name, last name and address. Next rule is transitive rule. That is, if x tends to y and y tends to z, means then ultimately x tends to z. So roll number tends to address, address tends to pin code, means your roll number tends to pin code. Next is secondary inference rules. The rule number 4, decomposition. Decomposition means we are just breaking the attribute. If x tends to y z, then x tends to y and x tends to z holds. That is, roll number tends to first name last name, then roll number tends to first name and roll number tends to last name. Union. If x tends to y and x tends to z, means then x tends to y z holds, which is roll number tends to name and roll number tends to address, means then roll number will tends to name and address. Last rule is pseudo transitivity rule. That is, if x tends to y and wy tends to z, means then wx tends to z. So these are all the Armstrong's axioms which are related to your functional dependencies. Next topic is normalization. So why we are going for normalization? Just to reduce the data redundancy. Now first we shall understand what is data redundancy and then we will know what is a normalization. So what is data redundancy and why should we reduce it? Now let us understand it by using an example. So there is a table with 4 rows. You can see the last column, it contains similar data, repetition of the same data, right? So x, 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 so all these are the repetition of the same data. So what happens is, the repetition of the data, it increases the size of the database. So because of this, we will have problems like insertion problem, deletion problem and updation problems. Now let us consider a student table. So with the attributes like roll number, name, branch, HOD and office telephone number. Now let us add some data. Okay, now I have added these details. So this branch, HOD and office telephone number, you can see the data is repeated for each entry of the name and roll number. So again, if I try to insert values, these detail, the branch detail, HOD and office telephone number will be repeated. So this is repetition of the data. So what happens is, the unnecessary data repetition, it increases the size of the database and leads to the following issues like insertion anomaly, deletion anomaly and updation anomaly. So what is an insertion anomaly? That is, for each entry like this, again and again you are entering the redundant data. Okay, so how many data you have entered? So totally 7 data you have entered. For 7 data there are 7 repetitions over there. So ultimately your database size is increased. Deletion anomaly. Now you have stored all the information in a single table, and if you are trying to remove some data set, means the other data set is also accidentally removed with that. See, in this table, in the students table, there are 5 data there. Now I am trying to remove the data. See, roll number and name, these two belong to student details, whereas branch, HOD and office telephone number, this belong to branch details. Now these two different data set are present in a single table. Now what I am doing, I am going to remove the data like this. So I have removed the data, but here the problem is that I have not stored the branch information anywhere else. So my branch information is present only in this table. So what happens? So branch information is deleted along with the student information. So my data is lost. So this is deletion anomaly. Now coming to updation anomaly, updation problem is that, now suppose my Mr. X was the HOD previously and he has been changed to Mr. Y as the new HOD. So I want to update this detail in the table. So I am updating, I am deleting the old data and I am updating. Suppose if I fail to update this information, what happens? So the row is not updated with a new value. So these are all the problems with the data redundancy. So how this normalization will solve all these problems? Let us see. The student table, it is split into two, that is student table plus branch table. Let us see how it looks like. So this is the old student table containing roll number, name, branch, HOD and office telephone number as the attributes. Now I am dividing this into two. One with a new student table with attributes roll number, name and branch. Another one is new branch table with attributes branch, HOD detail and office telephone number. So my branch or department table will look like this. So containing branch, HOD and office telephone number with the details. So here in the previous case you can see, the CSC and Mr. X office telephone number, this details is repeated for 5 times because it is stored along with the student information detail. So for each entry of the roll number and name, this details will be repeatedly stored. But if I maintain all these details separately in a separate table, like this branch table, so I can maintain only one entry. So this entry will be related with the branch detail in the student table. Okay. So the branch detail, this particular attribute, it is related to the student detail. So in the student table also I can have any number of entries which is related with a common attribute. So in the student table I can have as many entries as I want with a single entry in the branch table. So here also there is redundancy. So my point is, normalization, it does not eliminate redundancy, but it helps to minimize the redundancy. So you can see in the branch table you can have only one entry for each entry in the student table, where the branch is related with the branch attribute in your department table. Now, if I want to update any information like new HOD detail or office telephone number, I can do that in the branch table without affecting any details in the student table. So, this is possible with the help of normalization. Now, by reducing the redundancy, what are all benefits you will get? I can have few problems in the insertion, deletion and updation. So, let us see how the insertion problem is solved. Now, I am maintaining two different tables like student table and branch table. So, in the student table, I am inserting values like 4, Divya and CSC. So, for these detail, I am having only one entry in my branch table. Okay. So, now next is deletion problem. So, in the previous case, if I tend to delete the values of the student information, all the branch information is also deleted. But here, if I want to delete any student information, the roll number, name and branch alone will be deleted, and a copy of branch details is always there in the branch table. So, that will not be affected. So, see, I am deleting the details. So, even if I delete, even if there is no data in the student table, still I am having the data in the branch table. So, the deletion of one data set will not affect the another data set by reducing the redundancy. Next is the updation problem. So, here in the previous case, if I am updating a value and if I fail to update any row accidentally, then wrong information will be stored. But here, since I am maintaining a separate table, so I can able to update the value in a single table. I no need to update the details in all the tables. So, my time will be reduced. So, thus normalization, it solves the problem by divide and rule concept. As a result, we will get a logical, independent and a related data set. Now, let us see what is normalization in detail. A normalization is the process of organizing the data in the database. It minimizes the redundancy from a relation or a set of relation. It is used to eliminate the undesirable characteristics like insertion, updation and deletion anomalies. And it divides the larger table into smaller table and links them using a relationship. Now, let us see what are the types of normal forms. So, there are different types: first normal form, second normal form, third normal form, Boyce code normal form, fourth normal form and fifth normal form. In this video, we will focus only on the first normal form. In the upcoming videos, we shall see about the remaining normal forms. Now, how to achieve a first normal form? So, in order for a relation to achieve a first normal form, it has to satisfy four basic rules. What are they? Let us see. So, rule number 1 is each column should contain atomic values, that is single values only, and entries like x, y, w, x in the column 2. So, these are all not allowed and it violates the rule. So, this is rule number 1. In rule number 2, a column should contain values that are of same type. For example, take here, it is a date of birth. So, it is a date detail. So, here the first entry, that is first two entries are of date type, but the third entry it is a character type, or we can say it is a variable character. Similarly, you can see in the second column it is a name type. So, it should be a character type, but the last column you can see the date information is stored. So, we should not intermix different types of values in any column. It will violate the rule. Rule number 3 is a column should have unique name. So, here you can see both the column are having different, that is same name. So, it is a duplicate values. So, their name should be unique like first name and last name. If this is the case, then it will satisfy the rule. So, same names, it lead to confusion at the time of data retrieval. That is the problem. Rule 4 is the order in which the data is saved, it does not matter. Whatever data in whatever order, the data can be saved. With the help of SQL query, we can able to easily retrieve the data from the database. Now it's a time for example to understand how the first normal form works. So this is a student table with 3 attributes: roll number, name and subject. Now let's add some data like 101, 102, 103 and 104. Now I have entered 4 details in the student table. Now you can see in the subject attribute there are 2 entries which has multiple entries. There are 2 records with multiple entries. So it will violate the first normal form. As per the first normal form, first rule, each column should contain only atomic values. Atomic values means single entry, but here there are 2 entries for 2 records. Now how to solve this? So the solution is we have to split the values in the records. The solution is to split the values in the records, and then the table look like this. So for each entry the subject name is stored in a separate rows. So this is how the first normal form is achieved in a relation. Okay, so we have come to the conclusion part of today's class. So the topics which we have seen is, we have seen about functional dependency. So functional dependency is nothing but it is a relationship among different attributes in a relation. So functional dependency, it can be a trivial, non-trivial, multi-valued, full and partial dependencies are there. And that is data redundancy means multiple occurrences of the same data, and because of this the size of the database gets increased, and also it leads to problem like insertion problem, deletion problem and updation problem. And finally we have seen normalization. So to reduce the data redundancy and also to achieve some optimization in the table, we are going for normalization. So it will organize the data into multiple related tables. So in that we have seen first normal form, that is, it is a very essential condition for a table. Any table, it should at least be in the first normal form. So it is a primary criteria for any table in your database. So if a table is said to be in first normal form, it should contain only atomic values and it should contain unique attribute names. So the attributes can be in any order. Okay, so these are all the conditions to be satisfied. So with this I summarize that the topics which we have seen today is functional dependency, data redundancy and normalization. So we shall see about the other normal form in the upcoming videos. Thank you.